All right, hi guys, we're going to keep on moving along in chapter 4. We're coming to the end. We just have 2 more lessons. So this is lesson 4.8. I'm going to present my screen and we'll get started on our notes for today. Okay. So in this lesson, we're going to be talking about local maxes, local mins, and an even function and not function. Okay, so a lot of what we're going to do is either review or just a little bit of an extension of stuff we already know, which is kind of nice. Okay, so local maximum, the y-coordinate of a turning point of a function. So these polynomial functions that we've been graphing, as you can see down here, right, there's local mins and local maxes because there's more than one dip, right? If you think about the valleys as being the minimums and the hills as being the maximums, there's more than one valley and more than one hill in some of these polynomial functions. So each turning point, each valley, and each hill are what we call local maxes and local mins. The valleys are your local mins and your hills are your local maxes. So this is an example of a local max. Here I have an example of a local min. Okay, over here as well, here's a local min, here's a max, here's a min. So each turning point, right? And we're talking the y-coordinate associated with that point. So again, the y-coordinate of a turning point of a function when the point is higher than all nearby points. And the local min, the y-coordinate of a turning point of a function when the point is lower than all nearby points. Okay, because that's the lowest point in relation to the points that it's closest to. All right. Then we have what we call even functions and odd functions. An even function, or excuse me, a function, y equals f of x, is even when f of negative x equals f of x for each x in the domain. So what does that mean? And you're going to see, because I'll do an example. If you replace all of the x's with a negative x, and you clean it up, simplify it, and it comes out looking like the original function, then it's an even function. But if you plug in a negative x for the function, and it changes the signs of every term or some of the term, then it's going to be an odd function. So, or sorry, I should say all of the terms change signs. It's odd. If only some do, we'll say it's neither. And you'll see an example of that in a moment. All right, zeros, factors, solutions, and intercepts. Okay, let f of x equal polynomial function. All right, the following statements are equivalent. 0, k is a zero of the polynomial function. Factor x minus k, is a factor of the polynomial function f of x. Solution, k is a solution or root of the polynomial function, polynomial equation, f of x equals 0. And x-intercept, if k is a real number, then k is an x-intercept of the graph of the polynomial function. You know that we've been using those terms interchangeably, the zeros, the factors, the solutions, the x-intercepts, the roots, right, of the function. All right, turning points of polynomial function. The graph of every polynomial function of degree n has at most n minus 1 turning points. If a polynomial function has n distinct real zeros, then its graph has exactly n minus 1 turning points. And then this is, again, your even and odd functions, which we'll talk more about once we do an example. Oh, actually, I guess that's the first example we're going to do. My notes are a little bit out of order than what I was expecting, but that's okay. All right, is the function even, odd, or neither? So all you have to do for these is, as I said, replace all the x's with a negative x inside a set of parentheses, and then simplify and evaluate to see what happens. All right, so I'm going to have k of x equals, and then instead of x, I'm going to have negative x raised to the third minus 2 times negative x. Okay, so when I clean that up, if I have a negative and I'm raising it to the third power, so it's negative x times negative x times negative x, it's going to stay negative, right? If you multiply a negative 3 times, it stays negative. A negative times a negative is a positive 2x, okay? So since all signs changed, what do I mean by that? I'll point it out if you're not sure. Oh, I forgot my cube there. Sorry, guys. the x to the third became negative, and the negative x, or negative 2x, let me erase so I can see what I'm saying. So the x to the third became a negative, and the negative 2x became positive. Because all the signs change, that means the function is odd. Function is odd. All right, let's try it for the next one. So everywhere I see an x, I'm going to substitute in a negative x. So negative x raised to the fourth minus 29 times negative x raised to the second plus 100. So when I multiply a negative an even number of times, it's going to come out to a positive, all right? And here as well, a negative multiplied an even number of times is a positive, and then plus 100. So now when I compare f of x to the original f of x to the fourth, minus 29x squared minus 29x squared plus 100, nothing changed. So all the signs all stayed the same. That means the function is even. But if some signs change and some do not change, then you would say it's neither. So all signs change means the function is odd. Some signs change means it's even. Some change, some don't change. You would say it's neither. Okay. And again, if you want to read a little bit more about even versus odd functions, there's more information listed right above. Okay. All right. Next, it says graph the given function and state the following. Okay, so I have f of x equals 1/2 times the quantity x minus 1 times the quantity x minus 4 squared. So what we're going to do here, since it's already in factored form, is find the solutions. We'll talk about the number of solutions and so on and so forth. Okay, so, I need my pen. All right, so since this is already in factored form, let's talk about the number of solutions first. Degree 2, degree 1. Okay, so if I multiply it all together, it's going to have a degree of 3, which means there are 3 solutions. 3 solutions. But if you weren't sure, let's solve it and see how many solutions we come up with. All right, so you're going to set x minus 1 equal to 0, and you get x is equal to 1. You're going to set x minus 2 squared equal to 0. Take the square root of both sides first. So you have x minus 4 is equal to plus minus the square root of 0. That's just 0. X minus 4 is equal to 0. Add 4 to both sides and you get x is equal to 4. Okay, so your solutions are a positive 1 and a 4, but this is a double root. It's a repeated solution because it has a degree of 2. Okay, so I'm going to plot those as my x-intercepts. Let's make an xy axis nice and dark right in the middle. All right, go back to my red pen. So I have an x-intercept of 1 and an x-intercept of 4. Okay, now there we go. We could talk about whether it touches or passes through, which we'll talk about in a second, but let's talk about the end behavior. If the degree is 3, okay, 3 solutions, if it's an odd degree, what should the arms be doing? Both arms go in the same direction, both ends up, both ends down, one end up, one end down. You should have one end up and one end down, okay? So since you know that it's going to be one end up and one end down, then you have to think, well, is it this way or is it going to be this way? Okay, well, your lead coefficient is positive, so it's going to be this one, which has a positive slope if you were to stretch it out, right? So lead coefficient is positive. Okay, so I know what the ends look like, so I can kind of at least get the ends going. That's one end, and here's the other end. So now let's talk about touch versus pass. Because this has a degree of 1 and this has a degree of 2, all right, what happens when you have an odd degree? Does it pass or touch? It passes. And if it's an even degree, you touch. So that means for the answer, the x-intercept of 1, I'm going to pass through it and like go up a little bit. Then I have to start at some point turning and coming back down. And then I'm just going to touch and change directions and go back up. Okay, so that is a rough sketch of our polynomial. Did I plot the point at the wrong spot? No, that's right. Yeah, I copied the problem down wrong from my notes. That's why it doesn't look exactly the same, but that's okay. All right, so that is what the polynomial function should look like sketched out. Okay, so now we're going to talk about local max and local min. All right, so here I have a local min, and up here I have a local max somewhere. Okay, we'll have to figure out that point. Let's talk about the local min because that one's nice and easy, right? It's one of the points that I plotted. So that minimum value, that minimum point, think about the coordinate there. We're at 4, 0. All right, so your local min 4, 0. All right, and then the point right here is going to be your maximum. We don't know the exact coordinate of that point. So for this one, let's go ahead and use our graphing calculators. Oh, I closed mine accidentally a minute ago. Give me a second, guys. Okay, so I'm going to plug in that function that we have. Clear this. There we go. There's that. Okay, so I have 1/2 alpha y equals 1/2. And then parentheses, x minus 1, I think it is, right, if I remember correctly. And then x minus 4 squared. X minus 4 squared. Move it. There we go. And then I'm going to hit the word graph. Okay. So it looks similar to what I have, right? And then what I'm going to do is I'm going to hit second table to get a table of values. Maybe I will second table. There we go. A table of values that I can copy down onto my paper. All right, so I only really want to copy, the good, easy, smaller values, especially ones where I can see there's a change of direction. So I can see that my y values are all like negative here, negative y values, but now they've changed to positive. All right, and then you might notice here they go to a 0, a 2, but then it goes back down to 1, a 0, and then it changes again and goes to a 2. So I'm going to want to copy probably, I would say, these numbers right here onto my paper, okay? Let me see if I can do this an easy way. I don't know if this will work, but we'll see. And try to do snippet new. I'm sure you guys know about snippet, but I love it. I use it all the time. Okay, so then I'm going to go edit, copy, go back to my notes. All right, and then I'm going to paste it. That way I don't have to remember everything. Format. Oh. That's what I want in front of text. Okay, there we go. That way I don't have to remember all the numbers to copy down. All right, so the table of values definitely want to write down on your paper because it's going to help you identify the max, the mins, increasing, decreasing, all that kind of stuff. So I would just kind of set up a table, an XY value of, there we go. All right, so for this one, you can see here that this is an x-intercept, which we already have copied down or plotted on our graph, x-intercept. You can see that this is an x-intercept because they both have y values of 0. Okay, and then you can see that we change directions. Oh my goodness. So we changed directions, we set at 4, 0, right? So it's an x-intercept and we change directions. So it's also your local min. And then where else did we change directions? It looks like we went up to 3, 1 and then changed directions. So 1, 2, 3. We're gonna, again, it's just a sketch, so it's probably not graphed exact, but at 3, 1, we changed directions. So we're gonna call that our local max. All right, there's another way using the graphing calculator to figure out the local max, but from our table, we'll just call that the local max, okay? So your local max is 3, 1. Now you're increasing and then decreasing and then increasing. Now we've talked about increasing and decreasing before, but we're going to visit again. So we're increasing to the left of this point. So we're increasing when our x values are less than 3. And then we start increasing again to the right of 4. So we're increasing again when our x values are greater than 4. All right. And then we're decreasing. I'm going to have to erase this because I can't get down further without erasing because nothing stays put. Oh, never mind. I can just go like that and write it here. So we're decreasing between 3 and 4. So when our x values are between 3 and 4, that is where we're decreasing. Okay, I think the last thing we have to do is even, odd, or neither. So I'm going to erase all this so I can scroll down. Okay, so even, odd, or neither. So for this, just like we did in the first examples for today, what you're going to do is take the function f of negative x and plug in a negative for all the x's. So 1/2 is going to be negative x plus 1, and then negative x minus 4. Now, this would be easier, actually. I'm going to write it out. If we, let's expand it. It's a lot easier to work with it in expanded form. So let's go ahead and expand this function by multiplying it all together. Oh, it's a minus 1, not a plus 1. Because it's much easier to do the even, odd in standard form. So I'm going to first, remember that x minus 4 squared means x minus 4 times x minus 4. And then I'm going to FOIL the first two. So I have x squared minus 4x minus 1x plus 4 times x minus 4. Clean that up. So I have x squared minus 5x plus 4 times x minus 4. Then distribute the x in and the negative 4. So I have x cubed minus 5x squared plus 4x. Distribute the negative 4 in. So negative 4x squared plus 20x minus 16. All right. And then distribute the 1/2 in. So I have, and actually let's clean up first. So combine like terms. So I have x cubed, so x squared. So let's see. I have a negative 5 and a negative 4. That's negative 9x squared. Then the x terms, a 4 and a 20. That's plus 24x. And then a minus 16. Then distribute the 1/2. So I have 1/2. I'm going to write it up here actually. 1/2 x cubed minus 9/2 x squared plus 12x minus 8. All right. So the reason we went through all that actually, two things I'll talk about real fast is looking at this now. Maybe it was hard for you to understand at the beginning why I knew my lead coefficient was a positive number and my degree was a 3, an odd number. So expanding it could help you with that. But also now when I substitute in the negative x, it's going to be much easier to simplify from standard form to determine if it is an even or an odd function. Negative x. That's a negative, -8. All right, so when I have a negative that I multiply an odd number of times, it stays negative. So it's going to be a negative 1/2 x cubed. All right. If I have a negative that I'm multiplying an even number of times, it's a positive. So it's a positive x squared. Then a negative x times a positive 12 is a negative 12x, and then a negative 8. So did all the signs change? None of the signs, or some of them? For the 1/2, it changed. The 9/2 did not change. 12, it changed. 8 did not. So this is neither. Because some changed and some did not, it's neither. Okay. All right, let's see. There is one more. Let's see if we can go through this one a little faster. Okay, so this one is already written in standard form, so we won't have to multiply it all out. However, in order to come up with the x-intercepts, we have to factor it. Okay, so I'm going to write the function down below just so I can have some more room for factoring purposes. All right, so I have f of x equals x to the third minus 4x squared minus x minus 4. So let's see if this can be factored by grouping. X to the third minus 4x squared, then plus a negative x minus 4. Factor out a GCF of x squared to start. So I have x minus 4. Factor out a GCF of a negative 1, x plus 4. Did I have a copy error or did I make a sign mistake? No, that's negative, negative. Factor out negative 1, positive, positive. Oh, I did have a sign error right at the beginning. I think I copied the problem down wrong. Hold on. So the force of this, oh, I did see the force supposed to be positive. That's going to be helpful. Sorry about that, guys. This 4 is supposed to be a positive, which means when I factor out a negative, it's like grouping's not working. It's supposed to work. So now when I factor out a negative, it's x minus 4. So now my grouping works. I was hoping grouping worked. All right, so the common GCF is x minus 4. And then I'm left with x squared minus 1. This is a difference of squares, so it can be factored one more time. So it's x minus 1, x plus 1. So my answers are x is equal to 4, x is equal to 1, x is equal to negative 1. Okay, so I'm going to plot those points to graph. I'm trying to figure out how I'm going to graph this without having to move all over. Okay, you know what I'm going to do? I'm going to have to erase this, but let's talk about it for just another minute. So I have an odd exponent of 1, odd degree of 1, odd degree of 1. So am I going to pass or touch when I plot these x-intercepts? Odd degree means that you're going to pass. So you're going to pass through 4, pass through 1, pass through negative 1. Okay, keep that in mind. I think that's all I needed to know from factored form. So otherwise I can erase all this. So it's 1, negative 1, and 4. Pass, pass, pass. Okay. So let me scroll up now so I can graph that all. Okay, so it was negative 1, 1, and 4. Now the end behavior, let me go up that little bit. It is an odd, right? An odd degree. So I know one arm up is and one arm down. Lead coefficient's positive. So when I talk about sketching the graph, I know it's either this way or this way, right? Because it's a degree is odd. And since my lead coefficient is positive, I know that it should have a positive slope if I stretch it out. So that's what my arm should look like. This arm's going to go up, this arm's going to go down, which I'll do in a second. The number of solutions, well, because it's degree 3, 3 solutions. All right, so you can fill those in. I'm going to scroll back down. So I'm going to trace that. All right, so we said that one arm was up and one arm was down. We also said when we looked at the factored form that we're passing through each of them. So pass through, pass through, pass through. And I don't know because it's just a sketch how far down, like am I supposed to go all the way down and then back up? But it's just a sketch. I'm most interested in the x-intercepts, the end direction, and are you passing through or just touching? Okay. Now my table of values is going to help me with my local maxes and mins, increasing and decreasing. So let me graph now. All right, so I'm going to hit y equals, I'm going to type the function in. So the function is x to the third minus 4x squared. Oh, I'm still up in that. Minus 4x squared minus x plus 4. All right, so I'm going to graph it. Looks similar to what I had. Now, in the last problem, I didn't show you this, but I'll show you this real fast. If I wanted to know the exact value of that point and the exact value of this point, I could hit second, calculate, and go to maximum. We've done this before with other problems. So I'm going to go to the left of the maximum, like about there, just stay close. And then to the right of the maximum, stay close and push enter. And it'll tell you the maximum value, okay? And then I can, but we're not going to worry too much about it being like exact, okay? We're going to use the table of values instead. And then I'm going to hit second, calculate, and do the same thing for the local minimum. Right, so just go close to the minimum, but stay to the left, push enter, then go to the right of the minimum, push enter a third time, and you're given the exact minimum value. But we're just going to use the table of values. All right, I'm looking for like change of direction. So I can see my y's are negative. It goes from negative 18, it changes, it goes 0, now it's positive 4, but then it goes back to 0. It's going negative again, then it goes to 0 again and becomes positive. So I'm going to use my snippet tool. New. Okay, I want to have like this. Again, you could just copy this down by hand. I'm just trying to take some shortcuts so I don't have to flip back and forth a million times. Copy. All right, so I'm going to paste that here. Ooh. In front of my text. Okay, so again, I would be doing this by hand. Here's my XY table. All right, so I can see that I go from negative to a positive or to a neutral, 0, and then positive, and then I change directions again. So we're going to say that this is our max. Okay, we're going to say right here, and again, I didn't graph it up high enough. It should be all the way up here, but I'm going to say that 0, 4 is my maximum. So if I wanted to, 1, 2, 3, 4, I could fix my graph now that I have my table and go up to the 4. And then my minimum, so I'm going, let's see, it goes to The x-intercept is right there. It goes negative, negative, and then it changes direction at 4, 0, or goes back up to right there, right, 4, 0. So we're going to say that your turning point is right here, and that's going to be your local min. So your local min is 3, negative 8. Again, I didn't graph it low enough, so maybe I now want to change it. 1, 2, 3, and then down to 8. 1, 2, 3, 4, 5, 6, 7. It would be all the way down here somewhere. Okay, so if I want to fix my graph and make it look more accurate with my max and mins, now that I have them, I can. Okay, now those are the points that I need for my increasing, decreasing. So 0, 4, and 3, negative 8. I know that I'm increasing to the left of this point. So when my x values are less than 0, I'm increasing. Then I'm decreasing between 0 and 3. So when my x values are between 0 and 3, I'm decreasing. And then I'm increasing again when x is greater than 3, when x is to the right of 3. Okay. The last thing I have to do is even or odd. Let me erase all this. So for the even or odd, what you're going to do is write down the function. This one is already in standard form, which makes it easy. So it's x cubed minus 4x squared minus x plus 4. Substitute in negative x's and let's clean up and see what happens to all the signs. Okay, so a negative x cubed is negative x cubed because a negative multiplied 3 times stays negative. Minus 4, and then negative x squared would be a positive x squared minus x plus 4. So sign changed here from x to x, negative x cubed. Sign didn't change for the 4x squared. Sign didn't change, sign didn't change. So this is neither.
No, it's not.
Okay, and that's it. All right, guys, that is the end of that lesson. So let me just stop this. I will see you back here for the next lesson. All right, bye.